What is that another fancy way of saying? One rotation, which is also the period. So if they give you one revolution or one rotation, they gave you the period. So they give you the maximum, they give you the maximum. That one's easy, right? If they give you the amplitude, what word could they use instead of amplitude? I did this backwards by accident. What part of a circle would be the amplitude? Remember when we're doing this? Yes, this is half of it. So that is half the circle, correct? And what's half the circle? Radius. So amplitude and radius are interchangeable. What about the center of the circle? What could the center of the circle be interchangeable with? The midline. Because it's the middle, right? So those are definitions for one side of your paper, so you can remember the different words. One revolution period, amplitude and radius are interchangeable, center of circle and midline are interchangeable. Okay? Now I want you to turn your paper landscape. We had quite the debacle with hamburger and hot dog, so I think that's stupid, and I'm just using what we use in real world terms, which is landscape. Okay? I don't care if it's this way, I don't care if it's this way, but we're on a blank side, and we get a landscape. Okay? So whenever I'm given a word problem in trig, I will always sketch it if they don't give me an equation. So this question says, the height of a point on a Ferris wheel, h in meters above the ground as a function of time, t seconds, can be represented by a sinusoidal function. The max height of the Ferris wheel above the ground, so the max is 17 meters. The min is 1 meter, and it takes 60 seconds to complete 2 revolutions. So 1 revolution in what? In how much time? 30 seconds, which is also known as the period, correct? So what I will always do is sketch it. Now, what I mean by sketch it is on the left-hand side, I'm going to draw an actual Ferris wheel. And on the right-hand side, I'm going to draw an actual quadrant 1 Cartesian plane, which represents it over time. So, I'm going to draw a circle. Backfired. So I draw a circle to the left. And it's going to have a base. What's the base of this one? This is 1 meter, correct? So from here to here is 1 meter. We know that. And then I'm going to draw a Cartesian plane beside it. That's the same length. So all the way down to 0 and then over. So I'm matching it up. This height right here matches with that one. Do you see how they work? They match together. So what I will always do as well is I'll split it into 4. The Ferris wheel or whatever circular object, I split it into 4. So here is my center, correct? And my center is just my midline. And these are just my radius, which is the same as my what? Amplitude. We agree? Okay. So we are going to get coordinates at each of these spots. So this is what I'm going to do. I'm going to put a coordinate here. What's this coordinate at? Some 0 seconds. I'm at 1 meter. Then depending on which direction you go, if they give you a circle, you have to go in the direction they show you. But if I'm going to go to this coordinate now next, I actually have to show an arrow that shows which way I'm rotating. So I run an arrow along the side here that says Okay, I'm rotating this way. And then I have a coordinate here, and then I'm going to have a coordinate here, etc. So what's the difference? What's the coordinate going to be up here? What's the height? 17 meters, because it's my maximum. When is that going to happen? How do you know that? It's half the distance, or half the time to do one foot up. So this would be 30 seconds, and I'd be back down to 1 meter, correct? That's a coordinate. This one would be 15 seconds. I would be at 17. Now, how do I find my times along the way? Well, I just do 30 seconds, and I divide it by 4, because I'm splitting it into 4. And I get 7.5 seconds each stop, right? So this coordinate here is going to be at 7.5 seconds and some height, which we'll deal with in a second. This one is 15 plus 7.5, so it's 22.5 seconds and some height. Control yourself. All right. It's going to be hard, but I believe in you a little bit. All right. How do we find out what the height is? At that center, at the midline. How do we get it? Can we find the amplitude if we have a min and a max? Yes. We can find the amplitude and we can find the midline. The amplitude, if you have a min and a max, is very easy to find. It's the absolute value of the max minus the min divided by 2. So the amplitude is 8. How do I get my midline? I'm finding the average. So I'm going to do 17 plus 1 divided by 2, which is 9. It should work out if you plug those numbers in. So let's see. If this is 8 and this is 8, I should get to where I was. So my midline here is supposed to be 9, correct? So here I'm supposed to be at 9. Is that actually 9 to get me there? 1 for the base, 8 for the amplitude. Then this would be at 9 meters, correct? And so with this. If I add another 8 to 9 meters, what do I get? 17. So it actually works out. It should work out when you've drawn it. Okay? Then what I always do is I'll sketch this Ferris wheel with respect to time off to the side. So here's my 1, here's 9, and here is 17. I'm matching them up with the actual heights. And then I say height in meters. And then this one is going to be time in seconds. And I have 0, 7.5, 15, 22.5, 30. And I could keep going, correct? 37.5, just keep going, just keep going, just keep going, and I get more than one period. And sometimes they make us actually sketch these graphs out. So it's important that we can from a word problem. So if I plot the points that they gave me here, or I found for myself, I guess, is 0 and 1 is my first one, then 7.5 and 9, then 15 and 17, and then 22.5 and 9, and then 30 and 1. And so we have this, not mountain, we have like a rounded hill almost for sinusoidal graphs. So do you see it's that circular object with respect to time actually makes a sinusoidal graph. Now from that, can we come up with an equation? Yes. We've just done it. We're only doing cos ones this time to start with because it said cos. So when you were doing this, when I assigned it to you, it was cos. So we're going to stick with the 2 cos ones, and then we'll follow with the sine ones after. So if I just do my 2 cos equations, I get positive. What's my A value? What's my A value? 8. The amplitude. 8 or negative 8. Cos. Then what do I need next? The B, the period, not the period. I need the period to get B, right? So what is the period of this graph? 30. So B equals 2 pi divided by period. Why did I use 2 pi and not 360 degrees? It is a what? Starts with a W. Rhymes with word problem. It is a word problem. Word problems are always in radians. We wrote that at the top of this part of the booklet a couple days ago. So it's going to be 2 pi divided by 30, which a lot of people want to type into their calculators. Nope. Reduce it. It's pi over 15. So I'm going to get pi over 15, pi over 15, and I'll deal with the horizontal phase shift after. And these shouldn't be Y's, these should be H's, because that's what it says. And these are T's. The back number is the midline. What's the midline of this one? 9. It's the center of the circle. We also found it over here. So it's plus 9. Then we have to do the C value. Fun fact. Every single one of these X values is a C value of a sine or a cos graph. You just figure out which of the 4 it is. Now, why would that be? Well, if it's negative cos, I look for the closest minimum. Where is the closest minimum? It's on the Y. So is there any movement? No. So for negative cos, I could just go plus 0 or minus 0 or put nothing. I could just have a T. Right? There's no phase shift. So that's the bottom one, gets me the negative cos. That's if you get on the Ferris wheel at the bottom. If they somehow helicopter you in, then it would change it out. Now, this one is my closest maximum. So that's my positive cos. Remember, you're not moving to the Y. You were on the Y, and you are now over here. So which way are we moving? To the right, how many? 15. So I get T minus 15. And they asked you to get them cos equations. Well, I'm going to show you the sine ones as well, because it's better to be over-prepared than under-prepared. So I would have H equals 8 sine pi over 15, T something something plus 9. And then H equals negative 8 sine pi over 15, T plus 9. Now remember, to get the C for sine, you need the midline. We agree? So this is the intersection with one of the midlines, and this is the intersection with the other midline, which happens to be these values. Do you see them? So one of the sines is going to be 7.5, and one of the other sines is going to be 22.5 to the right. How do I know if this is positive or negative sine, the 7.5? I draw an arrow, correct, through it? And the arrow is going up. So what's this one represent? Positive sign. And then this one is an arrow going through but down, so it is negative sign. Both of which are going to the right. So this is 7.5 to the right for positive sign. Then we go minus 7.5. And then this one's minus 22.5. So it is much more helpful if you actually sketch the graph beside the circle. It's a lot easier to find your C values. So what I'm going to get you to do once you're done finishing that, you're going to go to your notes. I think it's page 33. It looks like this one. Page 33. It's this graph. You guys are going to try this one out on your own. It's another Ferris wheel question which gives you a little bit different information. You're going to answer all the questions. We're on page 33. So this one is different than the last one. The last one gave you the min and the max, which is actually the nicest because you can just fill those into your amplitude formula and your median formula and get the value. But this one Oh, I love when it adds random things to my stuff. This one has a radius of 10 meters. So here's 10 meters, and here's 10 meters, which is a fancy way of saying amplitude. It rotates once every 40 seconds. So at 0 seconds, I'm at 1 meter above ground level, and then back again at 40 seconds. So this is actually easier, but you guys, so many people will give me the wrong values. Please pay attention. This one gets done terribly badly. This here is a distance of 1. We agree?
Yes.
So where is the midline then? 10? People will tell me 10 and 20. Is that true? This one takes me 11 to get, because it's 1 plus 10, because it's from ground level. So this one happens at 11 meters. And then where does the maximum happen at? 21 meters. And then 11 meters again. And then it's every 10 seconds. Why is it? I don't know what it's doing. Okay. So if I wanted to go this way now, I can put an arrow around. Now, if you're given a Ferris wheel with an actual arrow on it, you can't just be like, meh, I want it to go the other way. That's not an option. You have to go whatever way they do. But if I drew this, I can go whatever way I want. So this would be 10 seconds, 20 seconds, 30 seconds. So I have 1, 11, 21, height in meters. I don't know why it's cutting out stuff. And then it wants 2 full revolutions. So I need to go to 80. 0, 10, 20, 30, 40, 50, 60, 70, 80. And then I have 0, 1, 10, 11, 20, 21, 30, 11, 40, back to 1, then 11, oops, it's up here, 21, back to 11, back to 1. So we have this going on. Okay, we need some equations. So, our equations need to be y equals, what's our a? What's our a? 10. So I have plus 10, minus 10, plus 10, minus 10. Cos, cos, sine, sine. Now, some people say, Mrs. Lepp, why are you doing all 4? Because they can ask for all 4. So I'd rather you be over-prepared and be able to do all 4 than you're only good at cos negative. And then they ask for something else and you're like, well, it's been a good run. All right. So, b. Where do I get b from? 2 pi divided by the period. So it's pi over 20. So I get pi over 20, pi over 20. If you're like, I wonder if Mrs. Lepp's going to give me something like this. Yes, she will. She's me. I will. Okay. Now I need to end with the d value. What is the d value? Plus what? 11. Okay. You guys are idiots. Okay. All right. Sound like a dying bird. Okay. What? I don't even know. Okay, cos. Negative cos, what's the c value for it? There isn't one, so I can just put an x. Positive cos is 20 to the right. Negative or positive sine is this first one, so it's 10 to the right. Negative sine is this one, so it's 30 to the right. Or you could have done 10 to the left, it would actually get you in the same spot. Now it wants the height at 15 seconds. That always throws people off. You literally just plug it in for the x. So I'm going to use the negative cos, it's the smallest. I'm going to go y equals negative 10 cos pi over 20 times 15 plus 11. And then people freak out. They're like, I'm trying to get it to graph. Why are you trying to get it to graph? Just type this all into your calculator. Where do you think the issue is going to happen? You're not in what? Radian mode. So when you type it into your main screen, when they give you the time, you have to be in radian mode. So I go -10 cos pi divided by 20, not 21, 15, plus 11. If I plug it into any of them, would I get the same answer? Yes. So 18 meters. For D, this is now y2, because it would be 15 equals -10 cos pi over 20 x plus 11. I would have to make sure my window fits. So I would go -10 cos pi divided by 20 x plus 11, and then I would have 15. Then there's going to be 2 spots where this happens in the first rotation. So this is y2, y1, second trace 5. Enter, enter, enter. And x equals 12.6 seconds. And sometimes you have to watch, because sometimes they'll say the second or the third time it crosses it. So you have to read, which is crazy, I know. 27.4 seconds.